Dr. Michio Kaku, one of the most respected theoretical physicists on the planet, recently made a statement that sent shockwaves through the scientific community. He's talking about 3I/ATLAS, and according to him, this cosmic visitor is far stranger than anyone initially thought. Stay with me, because what you're about to learn will change the way you look at the night sky forever. According to recent statements, Dr. Kaku has highlighted several deeply puzzling aspects of 3I/ATLAS that don't add up with our current understanding of physics and astronomy. He's not saying the sky is falling, but he is saying that this object exhibits properties that challenge our fundamental assumptions about how celestial bodies should behave. First, there's the trajectory. 3I/ATLAS is moving through our solar system at an angle and speed that suggests it's definitely not from around here. But here's the strange part. Its path shows slight deviations that can't be fully explained by gravitational forces from the sun and planets alone. It's as if something else is influencing its movement, something we haven't accounted for. Second, there's the composition mystery. When scientists analyze the light reflecting off 3I/ATLAS, they're seeing spectral signatures that don't match anything we've cataloged before. It's not quite like a comet, not quite like an asteroid, and not quite like anything we've seen from our own solar system. Some of the readings suggest materials or compounds that theoretically shouldn't exist in the forms we're detecting. Dr. Kaku has also pointed out the object's unusual behavior as it approaches and recedes from the sun. Most comets create beautiful tails when they get close to the sun, because the heat vaporizes ice and releases gas and dust. But 3I/ATLAS, its behavior is inconsistent. Sometimes it shows activity when it shouldn't, and sometimes it remains dormant when it should be releasing material. Now let's talk about what NASA and other space agencies are actually observing, because the data they're collecting is absolutely fascinating and honestly pretty confusing. NASA has been tracking 3I/ATLAS using multiple instruments, including the Hubble Space Telescope, ground-based observatories, and various satellite systems. They're essentially throwing every tool they have at this object to gather as much information as possible before it leaves our solar system forever. The observations reveal something truly bizarre. The object appears to be tumbling through space in a way that suggests it's not a solid, uniform body. Its rotation is chaotic, which typically indicates an irregular shape, or perhaps that it's made up of multiple components loosely held together. But here's where it gets weird. The tumbling pattern changes in ways that aren't entirely predictable. The size estimates for 3I/ATLAS keep changing, which tells us something important. When scientists first spotted it, they calculated one size based on its brightness. But as they gathered more data, they realized the object might be reflecting light in unusual ways, making it appear brighter or dimmer than it should be. This suggests either a highly unusual surface composition or a shape that's unlike anything we typically encounter. NASA scientists have also detected what they're calling anomalous acceleration. This means that 3I/ATLAS is speeding up or slowing down in ways that can't be fully explained by the gravitational pull of celestial bodies it passes. With Oumuamua, we saw similar anomalous acceleration, and that sparked years of debate and speculation. Now we're seeing it again with 3I/ATLAS, but the acceleration pattern is different and even more puzzling. Temperature readings are another head-scratcher. As 3I/ATLAS moved closer to the sun, scientists expected to see certain temperature changes based on its distance and the intensity of solar radiation. But the temperature variations they observed don't match the models. Sometimes the object is warmer than expected, sometimes cooler, and the pattern doesn't follow any known thermal model for comets or asteroids. What really has NASA scientists concerned is that they've been unable to create a consistent model that explains all the observations simultaneously. Usually, even with mysterious objects, scientists can develop a working theory that accounts for most of the data. But with 3I/ATLAS, every model they create explains some observations while contradicting others. The scientific community is currently engaged in heated debates about what 3I/ATLAS actually is, and the theories range from the conventional to the absolutely wild. Let's start with the more conservative theories. Some scientists believe 3I/ATLAS might be what's called a nitrogen iceberg, similar to what some researchers proposed for Oumuamua. This theory suggests the object is made primarily of frozen nitrogen, which could explain some of its unusual reflective properties and behavior near the sun. Nitrogen ice is shiny and smooth, which might account for the strange light signatures. However, this theory struggles to explain the anomalous acceleration and some of the other observed characteristics. Another mainstream theory proposes that 3I/ATLAS is a dark comet, an object that's somewhere between a comet and an asteroid. It might have ice deep inside, but a thick, dark crust on the outside that prevents us from seeing typical comet activity. This could explain why it doesn't always behave like we'd expect a comet to behave. But again, this doesn't account for all the observations. Some researchers have suggested that 3I/ATLAS might be what's left of a planet that was destroyed in another star system. If a planet were torn apart by gravitational forces or a collision, the fragments might have unusual compositions and structures that we wouldn't see in normal asteroids or comets. This is an intriguing idea, but proving it is incredibly difficult with the limited data we have. Now we get to the more controversial theories, and this is where things get really interesting. A small but vocal group of scientists has suggested that we shouldn't rule out artificial origins. Now, before you think we're diving into science fiction, hear me out. These scientists aren't claiming 3I/ATLAS is an alien spaceship. What they're suggesting is that we should at least consider whether the object could be some form of probe, debris from advanced technology, or an artifact from an ancient civilization. Dr. Avi Loeb from Harvard University, who made headlines with his theories about Oumuamua, has pointed out that we should apply the same scientific rigor to the hypothesis of artificial origins as we do to natural explanations. His argument is simple. If we see something that doesn't behave according to natural laws as we understand them, we should consider all possibilities, no matter how unlikely they seem. The debate has become so intense that some scientists have accused others of being too quick to dismiss unconventional theories, while others argue that extraordinary claims require extraordinary evidence. It's actually a healthy scientific debate because it's pushing researchers to gather better data and think more creatively about what they're observing. You might be wondering, okay, this is all fascinating, but why should I care about some mysterious object flying through space millions of miles away? That's a fair question, and the answer is actually pretty profound. The study of interstellar objects like 3I/ATLAS is teaching us fundamental things about the universe we live in, and that knowledge has real implications for humanity's future. First and foremost, every interstellar visitor is like a message in a bottle from another star system. These objects carry information about the conditions, materials, and processes that exist in other parts of our galaxy. By studying them, we're essentially sampling other solar systems without having to send spacecraft there, which would take thousands of years with our current technology. Think about it this way. If 3I/ATLAS came from a star system, hundreds of light years away, studying its composition tells us what materials exist around that star. This helps us understand how common certain elements and compounds are in the galaxy, which in turn helps us understand the potential for life elsewhere in the universe. Secondly, understanding these objects is crucial for planetary defense. While 3I/ATLAS isn't on a collision course with Earth, other interstellar objects in the future might be. These visitors come at us from random directions at incredibly high speeds, which makes them particularly challenging to detect and track. The more we learn about how they behave, the better prepared we'll be to handle a potential threat in the future. There's also the technology angle. The mysteries surrounding 3I/ATLAS are pushing scientists and engineers to develop better detection systems, more sophisticated analysis tools, and new theoretical frameworks. These advances don't just help us study space, they often lead to technologies that benefit life here on Earth. GPS, weather forecasting, materials science, and countless other fields have all been advanced by space research. Perhaps most importantly, objects like 3I/ATLAS remind us that we're part of a dynamic, interconnected galaxy. We're not isolated on our little blue planet. We're constantly being visited by material from other star systems, even if most of it is too small to detect. Every breath you take contains atoms that were once part of distant stars. Every element in your body except hydrogen was forged in stellar furnaces. In a very real sense, we are all made of star stuff, and interstellar visitors like 3I/ATLAS are our cosmic cousins. So where do we go from here? What are scientists planning to do about 3I/ATLAS, and what can we expect to learn in the coming months and years? The first priority is gathering as much data as possible, while 3I/ATLAS is still within range of our instruments. Every major observatory on Earth and in space is being tasked with studying this object whenever possible. Scientists are collecting data across the entire electromagnetic spectrum, from radio waves to X-rays, hoping that different wavelengths will reveal different clues about its nature. NASA has proposed several follow-up missions to study the next interstellar object we detect. The challenge with 3I/ATLAS is that we discovered it relatively late in its journey through our solar system, which limits how much we can study it. But scientists are working on early detection systems that could spot the next interstellar visitor months or even years before it reaches its closest approach to Earth. One of the most exciting proposals is the Comet Interceptor mission, a joint project between the European Space Agency and other partners. This spacecraft would be launched and then parked at a gravitationally stable point in space, waiting for the next interesting comet or interstellar object to be discovered. Once a target is identified, the spacecraft would be directed to intercept and study it up close. There's also the Legacy Survey of Space and Time, which will be conducted by the Vera C. Rubin Observatory in Chile. This survey will photograph the entire visible sky every few nights, creating an unprecedented data set that should allow us to detect many more interstellar objects. Scientists estimate that with this system, we might detect several interstellar visitors every year instead of one every few years. Dr. Kaku and other scientists are also calling for increased international cooperation in studying these objects. The challenges they present are so significant that no single agency or country has all the expertise and resources needed to fully understand them. By sharing data and coordinating observations, the global scientific community can piece together a more complete picture. Let's zoom out for a moment and talk about what 3I/ATLAS means in the broader context of our understanding of the universe. For most of human history, we thought our solar system was all there was. Then we discovered that the sun is just one star among billions in our galaxy. Then we learned that our galaxy is just one among trillions in the observable universe. Each of these revelations fundamentally changed how we see our place in the cosmos. Interstellar objects represent the next step in that journey of discovery. They're tangible, physical proof that the space between stars isn't empty. It's filled with wanderers, travelers, refugees from other star systems, all mixing and mingling in the galactic community. Some estimates suggest that there could be more interstellar objects in our galaxy than there are stars. Think about that for a second. We might be surrounded by trillions of these cosmic nomads, and we've only just started noticing them. Dr. Kaku has often spoken about how humanity is at a critical juncture. We're developing the technology to become a spacefaring civilization, to extend our reach beyond our home planet and eventually beyond our solar system. Understanding interstellar objects is part of that journey. If we want to travel between stars someday, we need to understand what's out there, what hazards we might face, and what opportunities might exist. There's also a philosophical dimension to all of this. The fact that 3I/ATLAS is so mysterious, so unlike anything we expected, reminds us that the universe is far stranger and more wonderful than we imagine. We've been studying astronomy for thousands of years, but we're constantly discovering that our models and theories are incomplete. That's not a failure of science. It's science working exactly as it should. Every mystery we uncover leads to new questions, new investigations, and ultimately, new understanding. So what do you think about 3I/ATLAS? Do you believe it's just an unusual natural object? Or could there be something more to the story? Drop your thoughts in the comments below. And if you found this video interesting, make sure to like, subscribe, and hit that notification bell so you don't miss our next deep dive into the mysteries of space.